Welcome back, Geometry Advanced. We are going to move on to section 11.4. Yes, that means we are skipping over section 11.3. So we are moving on to circumference and arc length. So that is our objective for today's notes. We are going to find circumference and arc length. Let's start with the circumference of a circle. The circumference, capital C, of a circle is found by taking 2 times pi times the radius, or you can just take pi times the diameter. Okay, so note that D is the diameter of the circle, R is the radius. Hopefully you already know that the diameter goes all the way through the center of the circle. Okay, so the whole entire thing would be considered the diameter, and half of the diameter is the radius. Okay, so the whole line that goes through the center of the circle from one side to the other is a diameter. Half of that is the radius. That's why if we use the one that has the radius, we multiply it by 2. Okay, so if you really need to, you could make yourself a little note. The diameter is equal to 2 times the radius. All right. Might be also helpful to remember that circumference is similar to perimeter. Okay, so the circumference of a circle is like the length of the outer edge of it. So it's similar to perimeter of some of our other shapes. So this means that our units will just be regular units. They will not be squared for circumference. All right, find the indicated measure. The circumference of a circle with radius 9 centimeters. If you really want to draw yourself a picture, you can. You don't need one. C is equal to 2 times pi times the radius is 9. We can multiply 2 times 9 and we would get 18 pi. This is considered an exact answer. So this would be our exact answer. If you were to multiply out the pi in your calculator, so you take 18 times, hit your pi button, the circumference is approximately, let's see, let's just round to the nearest tenth, 56.5. I should be putting my units on this since they gave me units. It would be centimeters for both. So this would be my approximate answer. It's usually just easiest to leave it as an exact answer. Sometimes it might be necessary to have the approximate answer, but I'll try to show you both on many of these unless it specifies. All right, let's move on. Remember, in these videos, you can always pause it, rewind it if I'm going too quickly for you. We are again finding the circumference on 1B here. The radius of the circle. Oh, we're finding the radius of the circle with a circumference of 36 feet. So this time they gave us capital C. So we have capital C is equal to 2 pi r. All right, well, to get r alone, we definitely need to divide both sides. We're trying to isolate the radius, so we should be dividing by 2 pi. So r will be alone. 36 over 2 does simplify. to be 18 over pi. Okay, it's not necessarily a pretty answer. Our units would still be feet. This would be the exact answer. The approximate answer is what we get when we type that into our calculator and get a decimal. So it would be approximately 5.7 feet. That's the approximate answer. Okay, so just make sure you pay attention to the directions of exact versus approximate. If I don't tell you, it probably would be acceptable to do it either way. All right, example 2. The diameter of a bicycle tire is 30 inches. To the nearest foot, how far does the tire travel when it makes 100 revolutions? Okay, so you can imagine this tire on the ground. And so you're imagining as this tire is rolling along, different pieces of it will be touching the ground. So for one revolution, the whole circumference will touch the ground. And then another revolution, the circumference touches it again. So really we want the distance of 100 circumferences. We also want it to be in the nearest foot. They gave the diameter in inches, so we'll also have to deal with that. So let's first find just the circumference. We'll go ahead and calculate it in inches, and then we can convert it. So circumference, they gave us the diameter, so let's just use pi times the diameter of 30. So our circumference is going to be 30 pi inches, but if I want that in feet, I would have to divide my inches by 12. So that would give me 30 over 12 pi feet. And of course, 30 over 12 will simplify. Divide top and bottom by 6. We'd get 5/2 times pi feet. Okay. So then we want to take that and we are actually going to multiply it by 100 revolutions. That's how many circumferences or how many times around we're going. So 5 over 2 times 100 times pi. Remember, multiplication's commutative, so you can multiply the 100 wherever it's convenient for you. I think it's best to do it right next to the 5/2, because then we can cross cancel and make our lives a little easier. If you cross out the 2 and the 100, just take half of the 100. Now 5 times 50 gives me 250 pi. It says to the nearest foot, so let's go ahead and multiply that out in our calculator. 250 times pi. It says to the nearest foot, so I'm going to go ahead and round it all the way to the nearest whole number, and that would be approximately 785 feet. You could have done it differently. You could have left it in inches the whole time and then converted to feet at the end, and you should have gotten the same answer. Okay, so we used the circumference for one revolution, multiplied it by 100 revolutions, rounded to the nearest foot. Okay, let's keep moving. Okay, I went ahead and filled in the notes. We'll talk through them. You need to make sure all of these get copied into your notes, so if you need to pause it, that's fine. An arc length is a portion of the circumference of a circle. So it's just like part of the outer edge. You can use the measure of the arc in degrees to find its length in linear units. So when we talk about the measure of an arc, it's in degrees. Measure, degrees. The length of it is in linear units like feet or inches or centimeters. All right, so here we've got a good diagram and setup to find the arc length. The ratio of the length of an arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So let's talk about that one piece at a time. The length of the arc, so arc AB is kind of similar to if I were to talk about segment AB. I just make it a little curved instead of a straight line. So that length over the circumference of the circle, which remember we find by taking 2 pi r or pi d, so that's one ratio, is equal to the measure of the arc, remember the measure is in degrees, over 360 degrees because there are 360 degrees in a whole circle. Okay? It's important to note that you will be able to find the measure of the arc if you have what is called a central angle. So here I noted that the measure of arc AB, this arc that they kind of marked here, is equal to the measure of that central angle that it comes from, ACB. Okay, so this angle and this arc have the same degree measure. We call it a central angle because it touches the center of the circle. If you need more time, go ahead and pause the video. I'm going to scroll down to the examples. All right, so here we've got example 3a. We're trying to find the length of arc AB. So that would be what I've got in my top left corner, length of arc AB. Remember, capital C stands for the circumference. This is the measure of arc AB in degrees. Over 360, it will always be 360 because we have a circle. So let's fill in what we know. We do not know arc AB. That's what we're trying to find. The circumference is 2 times pi times the radius, which they labeled as 9 inches. So we could fill that in. If you want to go ahead and write that as 18 pi, that's fine. Is equal to the measure of arc AB. Remember, the measure of that arc is the same as the central angle it comes from. So the central angle formed by that arc here, or by that pizza pie. Think about this arc came from this slice of pizza. So that's the angle that we want to use, the 45 degrees. Over 360 degrees. Okay, we can simplify this a few different ways. So arc AB over 18 pi is equal to, if you want to go ahead and simplify that fraction, 45 over 360, that might make it a little easier for you. It's not necessarily essential. You would just have to simplify it later. This does simplify to be 1 over 8. So in my opinion, that makes it a little bit easier. In order to get arc AB alone, we need to get rid of this denominator. So I'm going to multiply both sides by 18 pi. When I do that, it'll cancel out completely on the left side. So I'm left with arc AB equals, well, now I have 18 pi over 8, which will simplify. We could divide top and bottom by 2. Arc AB is equal to 9 pi over 4. And I'm fine with you leaving it as an exact answer. This would be considered exact if we were to multiply 9 times pi and then divide by 4. You could get an approximate answer, but I'm fine with that as long as we put our units on it. So 9 pi over 4 inches. Okay, if you need more time, go ahead and pause the video. I'm going to erase that so that I can bring back the next example. I'll leave that generic formula up for us. All right, on number 3B over here off to the side. Same setup, we're trying to find the length of arc AB. That's why I left this here. We're going to reuse this. So again, I don't know the length of arc AB. I do know I need to divide that by my circumference. So remember, circumference, you could write it as 2 pi r. So 2 times 15 would be 30 pi is equal to, we've got the same central angle, 45. So if it's going to be 45 over 360 again, I'm going to go ahead and simplify that to 1 over 8 right now. That came from 45 over 360. We just did that on the last problem too, so I'm just going to simplify it right away. In order to get arc AB alone, I multiply both sides by 30 pi. So we have that arc AB is equal to 30 pi over 8. Again, that will reduce to 15 pi over 4. And again, I'm fine with you having an exact answer. 15 pi over 4. We should have our units inches. Now, again, when we do a Google form on this, I might not have you put in units just because then it gets picky about how you type in your answer. But it is important to know that for circumference and arc length, your units are not squared. For circumference and arc length, it's just regular units, linear units, like how far you would walk. We'll talk about area again coming up here. Okay, but not today. Let's bring back that last example. Okay, here's example C. I would like you to pause the video and go ahead and try it on your own. And I'm going to pause the video and work it out. So when you restart the video here in a couple minutes after you do the problem, it'll have the solution up here. So go ahead and pause the video, work out 3C on your own, and see if you get the same answer that I do. All right, so I got an answer for arc length of AB to be 17 pi over 2 inches. I showed my work over here. Okay, so arc length over the circumference, so 2 pi r, or 2 pi times 17 gave me 34 pi, equals the measure of the arc, which you find from that central angle. Okay, so 90 degrees over 360. 90 is 1/4 of 360. So I was able to simplify that fraction before I multiplied both sides by 34 pi. So I multiplied both sides by 34 pi, came over here, and then I was able to reduce that fraction to get my answer. So if you did not get the correct answer, hopefully you see what went wrong and you are able to fix it. All right, a couple more examples on 4. We've got 4A, 4B, and then we are going to be done with notes for today. So for 4A, we are asked to find the circumference. That's great. Usually we would want a radius or a diameter in order to find the circumference, so we could just use our formula. However, they did not give us a radius or a diameter, so instead they gave us an arc length of AB. So this is similar to what we were just doing. It's the same setup with the proportions. This time we're trying to find the circumference instead of the arc length. So this time, that top left ratio, we're going to be able to fill in the arc length is 6.82. We don't know capital C, the circumference. That's what we're trying to find. Equals the arc measure comes from that central angle, 75 degrees, over 360 degrees. From here, you should be able to solve this just fine on your own. You've got a proportion, you need to cross multiply and solve. So if you want, you can go ahead and pause the video to do that calculation real quick. All right, so I showed my cross multiplying and then dividing by 75 to get capital C, the circumference alone. And I got 32.736 centimeters. Okay, I certainly would not round this number here, the 2,455.2. Do not round that. There's no reason to round it. I wouldn't really round the final answer either, unless the directions told you to, just because that's really not that bad of a decimal to write out. It's just a few places. If you have questions about how I got there, please let me know. But I'm going to go ahead and bring back letter B. All right, on letter B, we are trying to find the length. We're trying to find the measure of arc AB. So again, we're going to be using that same setup. The measure of the arc, which they labeled as 40 feet, over the circumference, which we would have to calculate here with the radius, set equal to the measure of arc AB, that's what we're looking for this time, over 360. Okay, so if I take 15.28 times 2, that's giving me 30.56 pi. You are going to have to multiply that out in your next step when you cross multiply. Or you could just wait and divide by it at the end. That's fine. But the moral of the story is I would not round things until it's absolutely necessary or till you get to the very end. Okay, so again, this ratio was the arc length, linear length, 40 feet, over the circumference, so 2 pi r, multiplied the radius by 2. I still have the pi there. Measure of the arc is what we're trying to find over that 360 that's always there. So go ahead and pause, do your cross multiplying. We'll see if we get the same answer. All right, so I cross multiplied, which is a little bit tedious with the pi and the decimal and all of that, and then solved for the measure of arc AB. So you can see down towards the bottom here that I got a not so nice decimal this time. And if we round it to the nearest tenth, that's actually going to make the whole number go up. So I'm fine on that one with rounding. Okay, the decimal keeps going on and on and on. That's fine. You can round it up to the nearest whole number on this one to 150 degrees. Remember that arc measure, not length, but arc measure with the M, is measured in degrees. The length is some linear unit like feet, inches, centimeters. All right, I'm going to stop the video there so that we don't make it any longer than it needs to be. Make sure you are sending me your questions, following all the directions for today's assignment in Google Classroom.